Hello guys, welcome back. So it's been a few days since I registered my stake pool. It has been producing blocks. It's been doing a good job. Let me just show you again in cardano-scan.io. I can come to the preview testnet and search for my pool CRSE, and it should appear here. And right now we are now on epoch 156. So my stake pool has been producing blocks consistently and efficiently. And now I think it's a good time for us to learn a few commands that will be very useful for you when you are actually running a stake pool. First one is Cardano-CLI query stake-snapshot. Let me just perhaps make this bigger as well so that you can have an easier read. And let me just come here. So I'm gonna use Cardano-CLI query stake-snapshot, testnet magic 2, stake pool ID. And the stake pool ID, I can of course get it from Cardano Scan. But also if you want to generate it on your own, of course we have seen this command before. It is Cardano-CLI stake pool ID cold verification key file. It will take your cold key, and the output format you can choose bec32 or hexadecimal. I like bec32, and in this case I am just redirecting the output to this file pool ID so that I can keep it on my machine here. So now let me just get back to Cardano-CLI query stake-snapshot, testnet magic 2, and it will take my stake pool ID. I will read it from the file pool ID and run it. The output is the active stake on the system for the 3 snapshots, and also it will give you the stake associated to this pool at every snapshot. Mark, set, and go. So very useful command for you to know how much stake you have at every new snapshot. Another very useful command that we're going to learn today is Cardano-CLI query leadership schedule. This is a very practical command that, how I see it, more useful for is like when you are planning maintenance of your servers, of your machine that is running your stake pool. Like you want to find an appropriate window to perform your optimizations or your updates or whatever task, maintenance task you are doing. So I am going to read my code verification key file from volumes, CLR, my USB drive, and from ZRSZ directory, code key. My Genesis file, my Shelly Genesis file is in this machine, but it is under configuration. Shelly Genesis, note that I am using a relative path here, it's totally fine. Now I can come here and again, volumes, CLR, CRSC for my pool ticker, reading the BRF signing key from my USB drive over there. And you have two options, current or next. Next will be for the next epoch. We will see that in a minute. Let's now query for the current epoch. This command is intensive in terms of resources, so just please be patient. So nice. So currently the latest slot is 13,354,645,674. So my next slot allocated, it is 1841. So I just had a block produced while we were talking here. Let me just see if it is right. Let me just refresh this and we come to blocks. And just 2 minutes ago, we have a block produced. So it is very useful for us to know that. And you can, of course, plan a little bit ahead with next. But next, there is a very important thing to consider. You can only query the next epoch once you are on the last part of the current epoch. And the last part is the last third of the current epoch. So in preview, epochs last 24 hours. So the last third is 8 hours. So right now, according to this, the next epoch will start in 5 hours and 16 minutes. So I am already within this last third of the epoch. If you query that earlier than that, the randomness for the next epoch is not already fixed, so you will get an error. But right now, I should be able to query the next epoch. So let me just run that. Again, it will take a couple of minutes to run. So now we have the schedule for the next epoch, and these are the actual slots that I have allocated for me to produce a block. Very useful command as well. Remember that when we produced our kes keys, we said that this key evolving signature is only valid for a certain number of rotations, a certain number of evolutions. So we can actually inspect the validity of our kes key file, and we will use this command, cardano-cli query kes-period-info, testnet magic 2, and we will need to provide our operational certificate. So in this case, I'm going to read it again from my USB drive, volumes, CLR, CRSC, op-cert. And this output is very interesting, and it is providing us a lot of information here. So we have the current kes period, it is 104. We have the end of the current kes interval. So basically, this is telling us when our key evolving signature will expire. So we will be required to renew our key evolving signature and issue a new operational certificate before it expires on epoch 157. Now we have the total number of max kes evolutions, which we know is 62. And together with that, we have start kes interval. So we started our validity for this operational certificate on epoch 95. So if we do something like echo 95 plus 62, exactly what we expected. It will expire on epoch 157 after 62 evolutions. Every kes period has 129,600 slots, so we are 6,800,000 slots away from our keys to expire. Now, another very important piece of information is that the operational certificate number, this is associated to the counter. Remember that when we created our keys, we produced the operational certificate counter. And this is the counter that is registered on chain. This one is the on disk. And basically, if we are producing blocks with the current operational certificate, these numbers must match. Very interesting thing to look at. If you just renew your operational certificate and you just submit it to the chain, but you have not produced blocks yet, this is the only time when these two numbers will be not matching. In this scenario, when I just renew my operational certificate, my on this certificate will be one larger than the on-chain counter. So very useful command, in particular for knowing when you are supposed to be renewing your kes keys and your operational certificate. Now, to actually renew the operational certificate, this is something that is relatively simple to do. And for that, let me just actually do it. I will need my machine over here. Let me just start it on. So, okay, it's on. So I'm just going to produce a new key evolving signature key pair. and I will produce a new operational certificate. Note that I am just not required to do it right now because I have plenty of time to do that, but there is nothing preventing us from doing it. So we can actually change our operational certificate and our kes keys at any time. This is, for example, in the case that your keys got compromised for whatever reason, you can always generate new ones and have them working right away in a very few moves. So let me just come here to my air-gapped machine. And the first thing that I want to do is perhaps move my current files to something like just renaming them so that I don't overwrite them just right away. Something like this would work. The same goes for the operational certificate. Let me rename it op-cert.cert.oath. Something like this would work. And with that, I am now ready to actually start generating my new kes keys. And now we have produced new kes keys, which is kind of what we wanted. And now with that, we are ready to actually produce a new operational certificate. And we will now use the kes-period-info, the kes period, and the current kes period is 104. So I want this new operational certificate to be valid starting from the current kes period so that I can use it right away. The out file, it is out file, out file, op-cert.cert, okay? And let me just do a quick ls here. So yes, from here, I'm going to remove my op-cert.cert, and I'm going to remove my kes.skey together with my kes.vkey. And now I'm ready to actually come back to my previous directory and kes.vkey and op-cert.cert. And with that, I can then bring them to my local machine and upload my signing key and my operational certificate to my server. There you go, and it should be there. It is now, so I can now start my service again. And now I can query kes-period-info test-magic2 operational certificate. And as you can see now, my operational certificate is saying that it is using counter 1, but what is on chain is counter 0. This is expected. This difference is fine now because I have not produced any block yet. As soon as I produce a block, this counter should be updated. If it is not, after a slot where I am scheduled to produce a block passes, then that means that my operational certificate is not valid, most likely because of a bad incremental. We will see in a minute how can we overcome this kind of issue, but first we need to make sure that what we have done here is working. And for that, the best thing I can do right now to make sure that everything is going well, let me just query my schedule. And okay, I'm in the wrong directory. Let me just come to here. Here I should be able to run it. There you go. So it's 1947. And in a few minutes, we are scheduled to produce a block at 1955. So in 7 minutes or so. So let's make sure that this is running well. It's running. And here we are. We are just about less than a minute away from our scheduled time of producing a block. 1955 with 49 seconds, and it is 1955 with 20 seconds now. So we are 30 seconds away from our scheduled block. Let me just have a search over here with forced, and we should see. And there it is. Trace forged block. So we produce the block 3B4C2. And hopefully it went well to the network, which is actually expected. Let me just check. A few seconds ago, 155.49. Yeah, so we produced a successful block with our new operational certificate. And actually, if we query kes-period-info again, we should see now that the on-chain counter has changed from 0 to 1. And actually, let me just try to generate a bad operational certificate to actually trigger a bad block, an invalid block, and let me then show you how to recover from that, okay? And what I'm gonna do now is try to produce a bad operational certificate. And you can actually accidentally generate one. And for that, let me just come back here to my guide over here. And the only thing I need to produce a bad one is to actually run this command 2 times. And now I'm going to produce a new operational certificate. I have done it now, so I have a issue-op-cert.counter. Now it's saying 3. But if I, for whatever reason, I make an accident, I run this command again, now my op-cert.counter will say 4. And if I use this one, so now I am here and I can use secure copy again to upload my files. So now here, there it is. So now the certificate counter is saying 3, and I will produce an invalid block the next time I'm allocated to actually produce one. And this is something that we are going to actually see happening in real time when we are scheduled to produce a block. And we are scheduled to produce our next block in 30-something minutes. So let's see it here in real time. You're just 20 seconds away from that. So let me just show you here. So we have forged a block, but we get this error, chain database error, invalid block. Counter over incremented. The on-chain value is 1, but our counter says 3. We already knew about it, but it could happen inadvertently. You know how easy it is to make a mistake. You just produce 2 operational certificates in a row, and that will over-increment your counter. So how can we recover from this situation? This is the important thing to know. We will need to issue a new counter file. And for that, we have this command, cardano-cli node new counter file. So I go with cardano-cli node issue new counter. It's new counter. It will take our code verification key file. And we can say code.vkey. Then we need the correct counter. So the one that we have on chain is 1. The correct counter will be 2. So we say -- counter value, and we say 2. And now we have operational certificate issue counter file. Let me name it op-cert.counter. I will overwrite my previous file. And now I can issue my new operational certificate. And now extract this one, bring it again to my local machine over here, copy only the op-cert. But for me to pick the new operational certificate, I will need to restart my node, so I will stop it. For clarity, I will remove my op-cert here. Now I can come back to my local machine and upload my new operational certificate with the correct counter. Let me go for it. So it should be here. And we should see that now we have the correct number here. We are expected to have a 2 here because the on-chain certificate says 1. So when we issue the new one, it should be incremented by 1 and exactly by 1. So when it is time for us to produce the new block, which should be in a little bit more than 2 hours, we should be able to actually produce a valid block, and we will actually verify that when it is time. And a few hours have passed, and we should be able to check whether we created this block at March 30th, and it was supposed to be 22:51 minutes with 56 seconds UTC. So let me come back to the block producer node and actually have a query. This is a query that we are going to use. A few things that we haven't used before. This G is for grep, so we can look for this particular message in the logs. And since 9 hours ago, and with this no pager so that it doesn't extend to the right, so it instead will be wrapping down. And forge block, this is the message that we were looking for, note how it highlights. And now, yes, this is the block that we were looking for, and of course we have some other blocks afterwards. So we produce the blocks, and if we come back here to the Explorer, we can check. I think it is this one. Looks like it is. Yes, it should be for the time. Let me just come back here. EB99. So yes, EB99. This is the block that we produced. It is on chain, so everything is back to normal. We have accidentally produced a certificate that is not valid because the counter was over incremented, and we have shown you how to recover from such a situation. And well, I think this is it for this video. It has been longer than I expected, but hopefully it was useful. So see you the next time. Thank you very much. Thanks for watching.